Hello. Hi, everyone. Thanks so much for joining us for this webinar. My name is Rina Nir, and I'm the CEO of RadBee. It's been several months since my previous webinar, so I'm really happy and excited to be here, especially that I'm going to be here sharing a story about a very recent project that I was involved in. And I think there is a lot of exciting and interesting and innovative pieces in it. Before I dive in, I'll just say that RadBee specializes especially in helping medical device, pharmaceutical, and companies in regulated industries use their Atlassian systems in regulated contexts. So I've been busy with that for many, many years. And on top of that, we also have the snapshots product, and I'm the project manager. And in my background, I'm a software engineer. I'm mentioning all these background pieces because in what I'm about to tell you, you'll see how my experience in all these activities has actually allowed us to carry out the project that we did in a very specific manner. So I'll be going with the presentation for around between 30 to 40 minutes. Let's see. And then we'll have Q&A. And I have my friend here. Saskia, are you around? Okay.
Hi.
So Saskia is monitoring the LinkedIn feed. And if you put Q&A there, she will make sure that we get to them. So it depends on what the question is, what the comment is. She might interrupt me midway during the talk, or otherwise wait until the end and raise the question. And if we don't get to answer a question, or you want to post something after the feed, that's fine too. We will be looking at the comments on the LinkedIn event and be sure to get back to you. Okay, so without further ado, I'll jump right in. Let me. So the story I'm going to tell you today is about true events. So it's really inspired by a true project that we were involved in recently, where a company had a very specific problem coming from the fact that they have a really successful product. It's a medical device. It's a capital medical equipment that is existing in hospitals around the world. And one of the problems or the challenges was that the product is still going strong after several decades. The product does involve, it's a very sophisticated product. It does involve software, and they do release updates to the software, updates to the hardware. And of course, they also need to do maintenance, hot fixes, and all the stuff that goes with the fact that you have a product in the field. And the same problem I can often see also in pharmaceutical when they have a production floor. A lot of the software that manages this production floor gets updated regularly, but overall, it's an old system that continues to be successful. And the challenge is how to continue and maintain this system for the next few years without keeping all the engineers who work on it working in the old ages. A last industry that I know and I'm familiar with firsthand that has similar problems is banking, and banking also have legacy systems that are modernized, are being updated, but what manages all the design control requirements and specification for these systems often get neglected and is stuck in the previous century almost. So the challenge or the project that we were tasked with was taking all the engineering data, the design controls, the specification, the requirements, the tests that were stuck in old legacy systems and bringing them over to Atlassian, to Jira and Confluence. The project as a whole contains several main pillars, and the main pillars in my mind are the fact that first you need to define the target Atlassian configuration. So you need to define the data model that you want to have in Atlassian and how the requirements, the tests, the specifications will be managed on Atlassian. This is something we are not going to go into deeply today, but there's a whole set of articles that I've written over the summer, and they will be available to you if you go on this QR code. It's available online, and you can look there and get inspired, see how what was the target configuration, more or less, for this project as well. There is a second super important pillar that is all the work with the teams. So in this case, we had many teams, hundreds of people across a big business unit that needed to move, and they needed to move with their data. So there's the whole aspect of business management, alignment with the team objectives, and so on. It's not the topic of our webinar. I'm not going to touch on it, but it's surely a very important topic. The heart of our engagement was how to take actually the data that is stuck in the old system and bring it over to Atlassian. And that's the focus of our webinar today. And the key challenge that was presented to us from day zero is that the data is actually existing in Team Foundation server. The system itself has not been upgraded since its 2013 version. We are now into 2026. No one is actually very sure about the level of knowledge with the system administrators. We are not allowed to touch the system in the sense that the TFS cannot be changed, cannot be modified, cannot be moved, cannot be duplicated. We did not have a sandbox. You only have one environment, which is the legacy production environment. And you have somehow to get the data out of that and bring it over to Jira and Confluence. And you have no one to ask about it because no one actually knows anything about that system. So this again is the type of things that you run into when you really use very old systems. And of course, to increase the stress, because of the heightened regulatory requirements, we needed to move all the data that pertains to devices that are actually existing still in hospital and served in the field. And it was super important that all the applicable data that may be requested in the future will be moved over, linked to all the different types of data that it needs to be linked. Otherwise, the migration cannot be seen as a success, and you will actually be stuck with needing still to maintain the old system. So without any extra pressure, we went on to work and we devised a method to approach that. Before going to the actual pipeline, there is one more thing I want to mention about the situation that we faced, is that the engineering data, so specifications, tests, and requirements, were held in the ALM tool, which was a Team Foundation server. But there was also a documentation management system. In this case, it was a subsystem. And like in every situation where you have an ALM on one side and a document management system on the other side, the files that are transmitted between them are Word and Excel. And when you have Word and Excel in use over 15 years, you are sure that the ALM does not have the whole source of truth, because it's always super, super tempting for teams to use this transition from the ALM to the document management system in order to correct the data or fill gaps in the traceability and write things that eventually are approved in the document management system because they are representing a complete traceability, but they represent a deviation from how the data is in the ALM. So to give you two examples to that effect, we had one of the type of files that we were given is this type of traceability report. And we had many Excels like that, pretty long ones. And the IDs that you see here are IDs of items in the ALM system. So it's exactly like a Jira key, but that's just a reference to the ALM system. And these were actual official documents that were a part of the documentation management system of certain releases. And it says actually that this user need is traced down by this requirement, that is traced down by this specification, that is traced down by this test ID. So there is an implied link here between those items, and this implied link does not actually necessarily exist in the ALM. So you need, if you get the data out of the ALM, you need somehow to recreate those links back in Jira, because of course, when the data is in Jira, we want everything to be linked and correct and complete. Another example of a similar phenomena is that we had Word documents that were somehow including data about certain components of the system, as well as specifications. So you had these table of basically requirements with numbers. And in an ideal world, there was an assumption that these numbers are actually items that exist in the ALM and should be moving to the to Jira by us getting the data from ALM. But the information about them, to big extent, was often here where there was not necessarily a correlation between what we had here and what we had in the ALM. So hence, when you have an ALM tool and a documentation management tool, which are separate and the interface between them are basically Word or Excel files, you know that there might be problems with data consistency and the source of truth, and you need to resolve it if we are to move to Atlassian and put everybody on good footing. So we want Jira to become the source of truth and have all these pieces of information. So with these challenges, we started the work, and I'm bringing you a little bit to the end, and we'll tell you about the process that we have devised in order to be able to meet the challenge. So we had a 8-step process, and I'll take you quickly through the process. The first step was we got the requirements for what fields from each of the items in the legacy systems we needed to extract. To remind you, we did not have knowledge of the TFS system, nor did we have anybody on the TFS side that knew to explain us how to extract the data. But we got the requirement. So we needed to figure out actually how to get the data out of TFS. Pretty early in the process, we discovered that there is actually no other way besides scrapping the database. So the only thing that we could get is read access to the database of TFS and also access to the user interface so that we can see how the things look in the user interface of the TFS. And somehow between these two things, we needed to figure out how to generate SQLs that will give us the information. And to generate those SQLs, first we needed to understand how to get the values of each of the fields that were required. Then there were an exercise to define the scope, and that means actually which are the requirements or which are the list of items that we needed to get from the ALM, and those were based on these Excels that I just showed you before with the traceability matrix and some other criteria. So we were given different document list and criterias, and all of them together constitute the definition of the scope of what needed to be extracted from TFS. Once we had 1 and 2, we could go on and do the SQL to extract the actual data into a CSV file. Once we had the CSV, we worked on the different columns with a customer to define how these are mapped into Jira fields. And we went on and imported it to Jira and to Confluence. I will show also what we have imported to Confluence. Then we needed to make sure that the production Jira and Confluence have exactly the same configuration in terms of the field, in terms of the drop-down value, custom fields, all these data. Once this was cleared, we did again a final export from the legacy database based on the same SQL queries, because remember, this took several weeks. And between this point and that point, the team continued to work and modify the data in the legacy system. So just before we did the actual production migration, we needed to do another final export and then proceed to production. And the big advantage of working with several CSV interim configuration, interim formats here, was that basically the customer could be involved in each of the steps that we did, review the outputs of the process, and give us green light. Because, of course, we could not be the only judges that we are correct. There were zillion details to understand, to align, and it was very vital that the team on the customer side applied rigorous verification, both the team that work directly with us, as well as the business teams that know their data better than anybody else. Now to what was really different with this project compared to all the previous projects of similar type that I was involved with in my career, is that these type of projects with these quantities of data typically required a room full of developers working together for very long stretches of time. In this particular case, well, it was not a one-man effort, but it was a 1.3 man type of effort. So basically the capacity that we had on the project was a full-time engineer, my colleague who was working on it full-time, and I was involved with the project for somewhere between 10 to 15 hours a week, sometimes less, sometimes a little bit more. So that is the capacity that we had for this project. And I can guarantee that if we did not pull all the help that we could get from AI, we would not have met the challenge. So I'm here today to tell you that AI is really a game changer for these type of projects, and I'll show you how we actually leverage AI. So we use 3 different AI engines. One was the Microsoft Copilot that really helped us reverse engineer the TFS database and do the initial very important step of identifying how to extract the data from TFS. Then there was massive assistance with Claude in working with the CSVs that we extracted from TFS and getting them ready and importing them into Jira. And I will go into a couple of examples there of what we did. And lastly, in Jira itself, we got some leverage from Rovo itself. Okay, so let's go into the details and see exactly what we did with AI. So just to share the scope of effort we had in terms of extracting fields from TFS, we had to tackle 6 different work item types. Each one of them had a different set of different fields that we wanted to extract. So what you see here is the amount of different fields. Yes, bugs were definitely the star of the day. We had to extract 34 different fields. And of course, not all fields are created equal. I just, to give you kind of an illustration, one of the fields that we needed to move over was the tags field. And the tags field is what we know in Jira as labels. And it was pretty important that work items will move from TFS together with their labels into Jira. And there is here a very condensed explanation about how the tags are buried, literally buried in the TFS database. To reverse engineer these complexities, we basically use Microsoft Copilot. Our basic assumption is Microsoft Copilot being from the same wheelhouse as TFS. Maybe it knows something about the internal schemes of TFS. Unfortunately, it really did not have all the knowledge we expected, but it gave us a big foot up. So it gave us a lot of tips, ideas, options, pointers, and each of the fields here eventually involved several hours of work between us and the Microsoft Copilot and queries into the database itself. But that was eventually doable. So something that would take us many, many more hours was really sped up by the use of Microsoft Copilot. So that was the first big thank you for the Microsoft Copilot. The second one that we used heavily was Claude, Anthropic Claude. The reason for using it was basically that I'm using it for other projects as well. I'm very familiar with Claude, but I can tell you I've never written one single script of Python until this project. But when we looked at the different problems that we needed to solve, I thought that Python would be the right language to develop those in. And we started very small, and eventually we really developed more than 30 different, you can call them utilities, you can call them scripts, you can call them whatever you want, programs. But these programs really carried a lot of the heavy lifting of resolving all the data transformation that we needed to do. So I will just give you maybe 2 concrete examples. One of the really annoying thing when you migrate generally things between systems into Jira is the fact that you want to migrate the links as well. And links are not, even in the normal way of importing data to Jira, links are always sticky because it's not an attribute of a single work item, it's an attribute of 2 work items. And in the import process, you need to be able to know the keys of the 2 work items. And if you are given something like that, this is not a Jira key on the left side, it's not a Jira key on the right side, and you need to massage it quite heavily to make it digestible through the manual interface that Jira provides for entering links. So pretty early in the process, we realized that the better way to do that is just through the API. So to have a process that reads the links from the CSV file in whatever logic we defined is the best logic, finds in Jira the data based on the TFS ID. So you first import the data to Jira, then you have data in Jira with those TFS ideas, and then basically you call to the Jira API and you generate each and every link. This, once we did it, it also allowed us to add different conditions. So for example, early on, we realized that in some of those Excel files we are given, there are errors. They are simply wrong because they link two types of work items that should not be linked in this particular way. And there was a requirement, okay, once you generate the link, generate it only if it adheres to certain requirements. And once you have a Python program that does it, it's very easy to tell Claude, okay, now you allow me to restrict you so that you will only create links if the two work items are of certain types. And that's what we did. I can say that now my Claude agent is very proficient in the APIs of Jira, of Xray, and any new variation of what we need to bring into Jira is very, very easy to do. And of course, the biggest achievement that we managed to do with Claude was the fact that we had more than 80,000 tests that we needed to move over. So once the SQL export was done, we actually had a couple of very huge Excel files or CSV files with test information. They needed to be lifted into Xray. No way that you can achieve that if you are not going through the API of Xray. So going through the API of Xray with Xray meant that we needed to have a program for that. We did the program. But nothing is perfect. We had a real adventure here, and I can also go back and show you. So the whole bunch of yellow scripts that you see here are the different scripts that we did in order to handle the import of Xray data and to check out what is happening with the Xray data once it's in. Now, one thing that happened to us in production, so not in production, but when we migrated to production, and of course, nothing goes smoothly. You can prepare yourself. You can do the migration to sandbox. But then when you eventually you get to the when you get to the actual real life production data, something goes wrong. And indeed, in this case, something did go wrong. We imported all the 80,000 tests into Xray, and I flagged to the team, all the tests are in, go ahead and verify at your end that you are happy. In the verification protocol, they needed to verify 150 tests against their origins in the original system and the new system, Jira. And out of 150 test cases, 148 were perfect, 2 were missing steps. So I'm getting a notification from the team, hey, we have these 2 tests, they don't have steps. Immediately on my side, alarm bell goes up. If they found 2 missing out of 150, we have more missing out of the 80,000. Where are they? It's not possible in any way, shape, or form via a report from Xray to get those tests that might have missing steps. So happily, Claude by that time was very versed in context, knows everything about the Xray API. I did a small research. I developed an approach, and I just required from Claude implement a program that does A, B, and C. So look at exactly these data. I also relied on the fact that you can extract a backup from Xray. So I extracted a backup from Xray, and the whole comparison was done between the original CSV that was supposed to be imported to Xray and the backup that I got from the system. And that was pretty quick because it did not involve heavy API calls into Xray for each of the 80,000 tests. It was just comparing the backup file of Xray with the CSV that needed to be imported. And within a short time, I had a list of exactly those tests that are missing. And indeed, we found out that out of the 80,000 tests that were important, around 0.5% of them did not have their test steps. So that was the typical problem. It's not that it's not that test had half of their steps. It's either they had all the steps that they needed to have, or they did not have any steps. Okay, so once we had these steps, it was then another short iteration to ask Claude to write a script that actually goes and fixes them from the CSV. So we did not do a re-import of the whole 80,000 tests from scratch. We just had a script that, based on the list of missing steps, went into Xray and updated each one of them. And again, within the time frame of the operational window, we could fix this problem that was not foreseen in advance because we did not see it happening in our sandbox experiment. So what's the conclusion for that? First of all, it's very important to have sandbox experiments, but we did that, and not in all cases you will find all the problems. And the second thing is, if you run into problems, it's very good that you have AI ready to help you immediately on the spot and speed up the whole process of resolving the problem. So the next example that I want to show about what we did with Claude was this beautiful, amazing implementation of how to bring specifications, legacy specifications, into Confluence. So going back to this Word document that I showed you before, we had a whole bunch of documents like these, and we wanted to transfer them into Confluence pages. I will show you in a second how the Confluence page looks like. Let me just open it. Yes. So when this document is brought into Confluence, it needed to have the Confluence approved setup for these type of documents. So this is the modern setup, which, for example, uses an app inside Confluence to provide e-signature for the document. This, of course, is not an element that existed in the original Word document. There should be some kind of a version history and approvals of all the versions and approvals that we have here inside Confluence. But we also want, at the bottom of the document, that was the choice of how these needed to be transported. We want to have the history that came from SAP, the approval that were there, and also all the change history. So this is one example of something that needed to be changing when we importing the document into Confluence. The other major change is that the requirements, all the specifications needed to become Jira items. So this, for example, is a specification that exists in the original Word document. Now it actually is a Jira specification. So this is the Jira specification. It comes with its own reference to where it was in the legacy system. And this here is a snapshot table. So it's not text anymore. It's a macro that pulls data from Jira into the way that the team now works when they transition into Confluence. And the challenge that was put for us, because there are so many of these documents, no one wants to manually actually go and transfer them into Jira and to Confluence. We needed to create an automatic system or an automatic program that does it. So we leverage the power of Claude, and I'm going to share my terminal here. So the first thing we will do is we will show you how it actually transverses the document, finds specifications that need to be specifications in Jira, and tries to put them into Jira. So I'm just going to copy and paste. There's a command here. Docx-to-Jira is a script that reads Word files, find in them things that need to be specifications in Jira, and uploads to Jira. So we'll run it, and the result is that it found 215 specifications, but it did not create any specification because it has an imperative that it will not create duplicates in Jira. So let's verify that it will actually create a spec in Jira if it's not existing. So this is one of the specifications, and let me just delete this one. So once I delete it, it no longer exists in Jira, and we expect, so this is the list of the specifications. The most advanced one is GAL-DC 255. We will run the same program again. It now found the same 250 specs. It skipped 214 that were already in Jira, and it created GAL-DC 260. Let us check if we have it. So we'll just refresh it. And indeed, we have GAL-DC 260. This is something that the script found in the Word document, uploaded it into Jira, and this just happened right now. Okay, so this is the first part. The first part is lifting all the specifications from the document into Jira, but only the ones that do not exist already in Jira, because if something was imported in a previous iteration, we don't want it to be imported again. The second part is creating those Confluence pages out of the Word document. And to do that, we have a second script. I will execute it here. It reads the same file. And if I'm lucky, it will create a new page. Let's open this page. So this is again the same page or a similar page to what we created before. It went, it found all the different blocks of information in the Word document based on the predefined structure. It brought it into a Confluence page that looks exactly like the modern Confluence page that we want. And then in the place of testable specification, we have a snapshot table. We will just press the button here, and all the specifications that are now created in Jira will be included in this page and ready to go for the future. So let me just move it here. Yes. And guys, I just want to stress, this is a result of collaboration between me, a person who has good engineering skills but has not written one Python script in her life, and Claude. So I thought that it is amazing that that this type of result can be achieved. Okay, so this is why I see Claude as my Swiss knife for this project and for other projects as well. Now let's see how Rovo helped us as well. So Rovo made one step that was very, very crucial and critical and painful for the project. It made it really, really easy. So one of the things that is typically a pain when you move data from legacy systems into Jira is that data comes into Jira as HTML strings. So all those long text, they land in Jira as HTML strings, and Jira does not necessarily know how to present them nicely. So we created a small automation with Rovo. We discovered by chance that Rovo really knows how to transpose HTML into a Jira-friendly format. And I will just now run it manually, but of course in big scale, we ran it automatically across all the items that we imported. It now runs the automation. Your automation is in progress. In a few moments, I hope I see that it actually completed. Let me just refresh. It should not take so long, but yes. So now my HTML suddenly become much more friendly. If I refresh this, I can see that indeed convert HTML description to Markdown is the automation rule in Rovo that was executed. And what was nice in it, so it's automation. Most of it is very deterministic. It has nothing to do with Rovo, but at the heart of it, there is an agent which we developed and is called HTML to Jira Markdown Pro. And we invoke it from within the automation and we tell it to actually do this conversion. And the amount of time that it took us to implement that was so speedy relative to all the other options that we have tested and contemplated. So that was really brilliant. And I wrote a whole article with technical details about how this is implemented. It's you can scan it here. You can go to the Atlassian community, find this article. Okay, so what did I learn from this experience? One is that documentation debt or ALM debt is just increasing over time. We had so much problems with the data and so much pieces of different types of data to cobble together because it has been such a long time that it needed to be moved over. So there is a cost of waiting. The second thing is that absolutely, the size of challenge was really, really huge compared to the resources that we had in order to tackle the challenge. and we simply could not manage it if we did not have AI. I want to say that across the different organizations, you have these projects that are super important, but on the other hand, super, super expensive and risky and complicated. Really, AI is a game changer there. I see AI not just as an increase on productivity, it basically makes certain project possible. And specifically for that project, we know that historically it's been a very hard nut to crack. And we were very proud to be part of a successful implementation there. Then the third point there, or the third lesson, is how important for Atlassian experts or solution consultants or whoever gets engaged in such operations, not to see themselves as someone who just works on the Atlassian side or who works just in a normal project. I don't know, I called it here fearless jailbreakers, just because the amount of problems and unexpected situations and suddenly unexpected requirements that came because we suddenly discovered that the data is in this shape or form or in another shape or form is not something that you can say, okay, you did not tell us in the time of signing the contract that this data, that this situation exists, or you did not tell us that we will only have access to the database or whatever. There was a problem, a real need to solve this project. And the hat that we needed to put on ourselves is the hat of jailbreakers. We will need to get this across. And then the last point is that we would all not be here and we would not be talking about a successful migration if the team that we were working on were not absolute heroes on their side. They had all this work of verification of our work, communicating with us, but also, and I think far more complicated, helping, supporting, motivating, aligning all those hundreds of people on the other side of the organization that needed to come into Jira from, yes, a very old system, but a very old system that they know a lot about and felt as comfortable as old house slippers. Okay, so yes, these are my 4 main takeaways. Yes, thank you for listening. And Saskia, I think you are somewhere here in my screen.
Yes, I'm
Yes.
here.
Hi.
Hi. That was a very impressive presentation and exhaustive. I guess this was quite a bit of work to get done, but the end result just looks amazing. So yeah, first of all, congratulations and well done
Thank
on
you.
that. Which actually brings me to a question, because you've been talking a lot about like how you got that done. Then the kind of obvious next question for me is like, now that you've gone through it, what would you further improve in the way of how you do those migrations for future projects? What kind of learnings did you get now that you've been through that and had time to reflect on what you were doing there?
Yes, so I think that from technical standpoint, one of the things is that as people who work with Atlassian day in and day out in migrations, there is a certain standard run book in Atlassian on how to do them. For example, there is an importer, a CSV importer into Atlassian. My conclusion is that when it's so easy to write those import scripts with or import programs with Python going via the API, this is a far more reliable way of doing this automatically, less involved in terms of effort. So basically, every time that there is kind of a tool provided by Atlassian, which is semi-manual and requires you to click around and to map, etc. Today, there is no reason in such large project. I'm not talking about a small thing that you do over a weekend, but in such projects that are of industrial scale, there is no reason to use those tools. You better off work through the API of the system. So that is my, let's say, number one takeaway. And generally speaking, more and more automation. So one of the problems with a project like that is that once the project is over, it's over. You don't need it anymore. In this scenario where I was talking about, we actually have another few migrations in the pipeline that are pretty similar. And what we will do, we will further automate the things that are currently manually.
And another question that popped up to me, especially also picking up what you said about automation now, how can we use this for other migrations? You've been talking a lot, or that particular use case that you were explaining was a TFS use case where you migrated from TFS to Atlassian. But to what extent are those tools that you presented, the approach you developed, also applicable to migrations from other legacy systems? How applicable, how transferable is that to other systems?
So it's actually, a lot of it is very, very transferable, because if you go back to the pipeline, one second, I will quickly find myself there. So if we talk about this pipeline, this point is the point of extracting the data from the legacy system is the only point that is really very specific to TFS. And then, of course, the generation of the SQL based on that. But since we used CSV as the major way of processing the data and preparing it into going into Jira, all of it is basically, all this part is just usable for any other migration. So as long as you can get the data into a CSV from the legacy system, so that's the part that is really system specific. It's either through the SQL or through the user interface of the system or through any other means where the system allows you to get the data into Excel. After that, it's all basically the same.
Right. But I also guess like there's if that weren't an option, there's also an AI who can help you with that, I figure.
Of course. Of course.
Wow. This has been really interesting. Thank you very much for sharing that. We do not have any more questions from the audience, so I'll hand it back to you.
Okay, great. Thank you. So I'm going to go to my final slide and invite, one second, here it is. Invite people to connect with me on LinkedIn. If you have specific queries about what I presented or our services in general, just drop me a line to this email address. And otherwise, I hope you enjoyed it, and I look forward to see you in my next webinar, which we will surely publish through the same channels. Take care.